You hear me? Yep, that's much better. Cool. So we had a little bit of a little bit of an incident. It's just a fire drill. We're 2 hours behind schedule. So I'm going to start again because there's a bunch of different faces in the room. My name's Mehdi. I'm a co-founder and director of Sigma Prime. And I'm here to talk to you guys about Lighthouse, our security-focused Ethereum 2.0 implementation. This talk won't be a very technical talk. Basically, my main objective is to provide you guys with insights into the Serenity development lifecycle from an implementers team perspective. And I would also like to be as transparent as possible and share a bunch of challenges that we're facing. Also give you guys an update on our funding status, and also share with you some of our latest achievements and the progress we've made over the last few weeks. So for those of you who don't know Sigma Prime, we are an information security consultancy, mostly based out of Sydney, Australia. We work closely with blockchain projects, mostly in the Ethereum space, and we're basically a collective of developers, academics, researchers, and security engineers. I put up a few of our clients' logos. So we've performed security assessments for projects like Status, Chainlink, our CryptoKitties friends, DAPA, and a bunch of others. So security assessments are pretty much the core of our service offering at Sigma Prime. But I'm not here to talk about that. I'm here to talk about Lighthouse, since we're the maintainers of this project, which is a Rust implementation of Ethereum 2.0. Just to give you a bit of background on this project, we at Sigma Prime are very, very passionate about proof-of-stake designs, so very much into the game theoretical principles of algorithms like Cassper. We're also very, very excited about the environmental impact of proof-of-stake blockchains for our ecosystem as a whole. And we're very, very interested in the mathematical finality that some algorithms like Cassper can bring. Just a bit of history on Lighthouse. My friend and co-founder Paul started working on the JavaScript implementation of Vlad's Cassper, so Cassper TFG. So he basically built the JavaScript simulator, and he quickly realized that this consensus algorithm wasn't going to be the one being introduced in Serenity, or at least in the first iteration of Serenity, and he wanted to have the most impact. So he shifted his efforts towards Vitalik's Cassper, so Cassper FFG. And I'm not sure if you guys remember, but last year there was an effort or an initiative called EIP 1011, which was basically introducing the concept of a hybrid proof of work and proof of stake chain. This got deprecated quite quickly, I'd say, in the sense that we basically realized that having a consensus voting smart contract was was quite challenging with the current EVM bounds, and things like transaction ordering and gas metering were not necessarily adequate with the current EVM design. So this got deprecated, and the ETH2 spec was born. And the ETH2 spec was born as a result of the merge of two research initiatives. The first one is the sharding research initiative, and the second one is the proof of stake research initiative. And so researchers realized that there was a lot of overlap between the two, and basically this gave birth to the ETH2 spec that you were familiar with. And that's how we all started. I want to thank Danny Ryan, for making us feel welcome, making us feel safe, to basically start contribute to this project. So why are we doing this? We love Ethereum at Sigma Prime. We've been involved with Ethereum since the very, very early days. We love the community. We've learned a lot from the community. And we also truly believe in Ethereum's potential for changing the world for the better. As I said earlier, we're also passionate about proof-of-stake chains. And yeah, working with the research team of the Ethereum Foundation is very challenging and intellectually stimulating, and that's something we value a lot. So this keeps enhancing and expanding our knowledge, and yeah, we keep learning on a daily basis. And someone's got to do it. So when we started this project, there weren't that many implementations of Ethereum 2.0. I believe, if I recall correctly, that Lighthouse was actually the second one to be officially announced. Nowadays, there's new projects popping up almost every week, which is good. But yeah, back then when we started, there was not that many of them. So this is our way to sort of contribute and give back to the community. So I expect everyone to be familiar with the Ethereum roadmap, but just to make sure that we're all on the same page, I'd like to take a couple of minutes to basically touch base on a couple of concepts. I don't know if you guys attended Justin's talk yesterday about the Phase 0 spec. An amazing talk. If you haven't, highly recommend watching the video. But don't have time, obviously, to go into that much detail. But I think it's quite important to keep in mind the design goals. Why are we doing this thing the way we're doing it? I tried to group them in 4 categories. The first one, obviously, is decentralization, right? This is common to any sort of blockchain, but it's a very important goal in the sense that the researchers have designed this system in a way that we'd be able to run it or be able to be part of this network with a standard consumer laptop. That'll be massive change from the proof of work world, and that's quite important. Also, in the decentralization sort of realm, the fact that we can have a large number of validators is very important. As of today, we have the ability for the Beacon chain to support up to roughly 4 million validators, which is pretty cool. The other design goal, or another design goal, is liveness. So you may have heard some of the Ethereum Foundation researchers talk about black swan events such as a Third World War, which would introduce massive network petitions. So how do we ensure that the Beacon chain or the Ethereum Serenity chain is basically resilient and live and stays alive in such scenario? Is one of the key design goals again. The third one always makes me smile, simplicity. I wouldn't say that the Beacon chain is simple, not really, but it's good to keep in mind that it was designed in such a way to maximize the simplicity, and even if it's at the cost of some potential efficiencies. And last but not least, the security aspect is, of course, very important to any blockchain platform, and it's quite, at least interesting for me, the fact that we are using quantum secure cryptographic primitives where possible, and where not, well, it should be relatively easy to swap them in the future. So I'd like to think as the Ethereum Serenity chain as a future-proof chain, if that makes sense. Again, I'm hoping, or I'm guessing, this is familiar to most of you, but just taking a couple of minutes to walk you through it. So Phase 0 is basically where we're currently at, or what we're currently focusing on as implementers. And Phase 0 is basically the Beacon chain, right? And the Beacon chain is a proof-of-stake chain. It introduces Casper FFG, and it's basically responsible for storing and managing a set of validators and assigning them to certain duties. It's already going to provide mathematical finality to the ETH1 chain, even though some potential enhancements and tweaks that may require hard fork will be needed. Hard fork on the ETH1 chain, that is. And just to make sure that we're on the same page, the way it's going to work, we're going to have a smart contract on the ETH1 chain, on the current chain, and then if you want to become a validator, you send a deposit, a 32 Ether deposit to this smart contract, and after reaching a certain threshold, the Beacon chain becomes activated and comes to life. So that's Phase 0. Phase 1 is when we start having shard chains. as of today, we're going to have 1,024 shards, and basically we won't have state execution on those shards yet. We'll basically just get the validators to come to consensus on shard chains data. Phase 2 is what gets us to an actual usable, workable blockchain. And state 2, brings in state execution at the shard chain level, and as I said, yeah, that's when we actually get to play with a blockchain similar to the blockchains that we know today. Hopefully that makes sense. In terms of development lifecycle, this is what it looks like in an ideal sort of scenario. In reality, it's much messier than that. But I guess for phase 0, this is where we're at today, right? So taking the spec, testing it, developing some of it, finding bugs, looping those bugs, those findings back to the Ethereum research team, who then proceeds to update the specification, and then more implementation, more testing, and so on. It's a very iterative process, and we're currently, I'd like to think that we're at the end of this phase, and we're currently working on a single client testnet. So, hopefully within the next few weeks, we'll have a testnet for you guys to play with. It's a single client testnet, meaning that it's a lighthouse testnet. The next step is to get a multi-client testnet, where we get various different implementations and get them to connect to a common test network. After that, or probably around the same time, we'll get a bunch of independent security reviews to make sure that we haven't missed any sort of security bugs, and then we'll get a mainnet. Please don't quote me on this. This is not a commitment to any timeline. It's just my wild guess. It's a software project. Software projects, by definition, get delayed, especially when you're dealing with cutting-edge technology. So I'm guessing we'll potentially see a mainnet by the end of the year or early next year. Well, at least that's what we're working towards. So hopefully that makes sense. There's a bit of a sort of background on what Serenity is, and I'm going to spend some time talking about our client and how it's actually architected. So I have a little animation for you guys. So today, when you connect to Geth and Parity, some of you use the CLI, command line interface, so we'll have the same thing. Lighthouse will also have a command line interface. We have key stores in Geth and Parity. We'll have the same thing in Lighthouse. But ideally, to achieve mainstream adoption and user adoption, we want all this to be completely abstracted for the end user, right? So ideally, in an ideal world, users will just hit dApps, use dApps, be it mobile apps, web apps, or even desktop apps, and then this layer will then connect to the various APIs exposed by Lighthouse, and also potentially hit the wallet. In terms of peer-to-peer networking, it's a blockchain, so it's obviously a peer-to-peer network. So the critical sort of phase in the bootstrapping process is the peer discovery, making sure that we're able to identify peers that we can connect to and exchange information with. And the wire protocol basically dictates how we communicate with these nodes. And once you do your network discovery, you put this information in a database for further and faster processing. Then we've got the specification. And the specification basically dictates how the blockchain logic actually works and what the consensus agent should be doing. So in Lighthouse, we basically split these two components in two separate binaries. This is the beacon node, and this is the validator client. Just a couple of words on the networking layer we're using libp2p as the base sort of peer-to-peer networking stack. It's being developed and maintained by our friends at Protocol Labs. So these guys are the folks behind projects like IPFS and Filecoin. And the message routing we'll be using is GossipSub. And GossipSub ensures efficient network communication, especially in the context of 1,024 shards. It's quite important. So the beacon node mentioned is the core part of the Lighthouse client, which basically handles the fork choice rules. The fork choice rule is basically the algorithm that ensures that all the different implementations and different nodes come to consensus on a canonical chain. This is also where you have your state transitions, your block processing functions, and this all comes from the spec again. This is just an implementation of the specification, which comes, which is shipped with a bunch of test vectors that allows us to basically make sure that our implementation is on par with the specification. The validator client, as I said, is a separate binary, and it connects to the beacon node. Connects to the beacon node via a gRPC connection, and it basically polls the beacon node for certain information. So it fetches validator duties, and it's responsible for probing and asking the beacon node to basically propose blocks when necessary. This is how you sign attestations and how you propose blocks. So hopefully that makes sense. I started this talk by saying that Lighthouse is a security-focused Serenity implementation, and I want to tell you guys why or what it actually means. So first of all, we're using Rust. I'm not sure how many Rust developers are in the house. Probably not that many. Yeah, a little bit, a few. So Rust is quite awesome. We love Rust at Sigma Prime. It's, I guess, at least from my perspective, it's the result of decades of computer science research. It was developed in 2010 by the Mozilla Foundation, and it's don't have much time to go into much details, but it's safe. I mean, it's fast, sorry, and it's got very interesting security properties. So the way concurrency is handled is very, very elegant, and the memory management is quite innovative. Other security sort of principles we try to follow. One of them is sticking with the Rust philosophy, which is never panic. So a crash is a panic in the Rust world. So we don't want to panic, and we want to be able to safely handle and catch all errors and exceptions. We're also following strict coding guidelines. So there's this cool French institute called ANSSI, which is responsible for looking after information security for a bunch of French institutions. They're putting together a strict coding guideline book for Rust, and we're trying to stick with that. We're obviously using linters, things like code formatters, and we'd like to do more code reviews, but for that we need your help. We need more contributors so that we move away from implementing those functions ourselves and basically start reviewing the community's sort of contributions to this project. And we do a bunch of fuzzing, and I am particularly interested in fuzzing. So fuzzing is the process of essentially sending a bunch of randomized and unexpected input to software with the intention of causing crashes and unintended behavior, abnormal behavior, basically. And that's something we try to do quite a lot. Currently focusing on the crates or the Rust libraries that are consuming user-supplied input or networking information. And that's it's quite fascinating. So we're using two different fuzzers at this stage. We haven't really decided which one we'll go with in the long run. So libfuzzer and AFL, they're both coverage guided white box in process fuzzers. I quite like AFL. So AFL is the American fuzzlop, and it's when I was researching the fuzzing world a few years back, I was quite impressed at its capabilities. So there's this security researcher a couple of years ago who pointed AFL at an image viewer, a Linux image viewer, I can't remember which one. And basically AFL, because it starts to identify all possible code paths, AFL basically managed to create JPEG images out of thin air, which is quite cool. Other security considerations for the future, we expect bugs, lots of bugs, to arise from the testnet phases, particularly around denial of service attacks. there's, as I said, we're using libp2p, and there's, potential Sybil attacks in libp2p that are quite interesting to look at. And it's also, because we're taking the spec and optimizing it, there's potentially going to be consensus divergence and consensus-related bugs. So, that's normal. That's why we're going to have a multi-client testnet, and these things are basically good to spot in a test network. Before the actual mainnet release, I think I mentioned this earlier, we want to get an independent security reviewer. So we're connected with a bunch of, I'd say, peers in the space who we trust and really respect, and we're very much looking forward to them taking a look at our code. Formal verification is a very hot topic in the space. There's a lot of debates going on formal verification. So there's actually 2 teams, one in Singapore and one in Shanghai, working on formal semantics for Rust in K. So hopefully these guys will complete their work within the next few months. And when they do, that means that we can formally verify at least a subset of Lighthouse, which is quite cool. And I would also personally like to see a differential fuzzer. So the difference between a standard fuzzer and a differential fuzzer, and actually the Ethereum Foundation has a differential fuzzer. And what they do is basically they send random inputs to both Geth and Parity and collect the EVM artifacts or the EVM traces and make sure that they produce the exact same traces. This allows you basically to make sure that different implementations behave the same way. And that's how you catch consensus-related bugs. So hopefully, after a multi-client testnet is up, hopefully we should all work together to create this sort of similar project for ETH 2.0. Some of our achievements and progress update over the last few weeks. So I mentioned Gossip Sub as the message routing algorithm for libp2p. Well, turns out there was no Rust implementation when we started, right? There's only a Go implementation, and Adrian Manning, one of our co-founders and directors, just submitted a couple of weeks ago, I believe, a beast of a PR to actually implement Gossip Sub in Rust. So that's quite cool, quite exciting. Very much looking forward to our friends from Protocol Labs to merge this to master hopefully soon. We've also finalized a bunch of libraries, critical libraries for our project. So the SSZ library, the SSZ is the serialization format being used in Ethereum Serenity. The shuffling, the BLS, all these libraries are now finalized, which is great. We have proper block processing, and the 3 state transition functions have been implemented, which is quite exciting. I believe we're still have to upgrade it to the latest version of the spec, but it actually may have been done yesterday or this morning. The fork choice rule has been implemented, which is quite exciting. So we're using LMD Ghost for phase 0 at least, and that's all implemented. And yeah, we actually now have a beacon chain, which can build blocks and produce blocks with a few thousand validators, which is cool. So lots of progress was made by the Sigma Prime team on Lighthouse over the last few weeks. Another sort of aspect from a team perspective, we hired a new Rust developer who actually started with us 2 days ago. So Michael, welcome to Sigma Prime, welcome to Lighthouse. We keep contributing to the spec by finding more bugs, and making sure that the Ethereum Foundation is aware of them, and some of them may actually result in spec changes, spec updates. So yeah, I said I was going to be, at least try to be as transparent as possible in terms of funding. I think that's very important. I see Lighthouse as a public good. And yeah, so just giving you some context, some numbers on the funding status of Lighthouse. This project was bootstrapped and kickstarted by Sigma Prime. We dedicated a lot of time, a lot of resources and effort into making sure that this actually, gets started. So we estimate at roughly $110,000 the amount of money Sigma Prime has contributed so far. We also received a grant from the Ethereum Foundation back in October, I believe, worth $150,000. And then you may have seen on Twitter the YOLO grant. So Vitalik, sent 1,000 Ether to 3 teams back in December, late December last year, and we're one of them. So Vitalik, thank you so much. And we also keep using Gitcoin to fund some of these, GitHub issues, and it's been a real pleasure working with these guys. So it's a huge project. Funding is definitely a challenge, but it's challenging. But we're not the only ones. It's not specific to the Ethereum space or the blockchain space. It's an open source project, and as any open source project, it's funding is a challenge, is an issue. One thing I'd like to say, this is probably an unpopular opinion, but I don't think teams like ours should be holding their grants in volatile crypto assets, right? That's my take. That's just my opinion. But we have salaries to pay. We have developers that we pay them in fiat money, in Australian dollars or US dollars, and basically, we don't hold on to these grants in crypto assets. We basically, when that 1,000 Ether was given to us by Vitalik, we made sure to exit it and convert it to fiat within the next 24 hours. Well, at least 90% of it, 900 Ether, was actually sold within 24 hours. Why? Because I believe we shouldn't be speculating on public money. You guys are contributing to this, and we're, as I said, paying salaries, and it would be, in my opinion, irresponsible to speculate on the Ether price. As I said, this is not a problem that's specific to Ethereum or specific to Lighthouse or even the blockchain space. I actually believe that we're quite lucky to have the EF support projects like ours. Don't have that much time to go into details, unfortunately, but there's a bunch of different ways you can fund open source projects. And I guess it's up to us to find the right sustainable business model for Lighthouse. I want to commit today to you guys, to the community. Lighthouse is and will remain an open source and free Ethereum client. There's no ICOs, no tokens, no licensing fees. That's very important to us. In terms of funding, actual funding, this is the current team size. So we've got 3 full-time lead developers working on Lighthouse at the moment. We've got 1 lead developer or core developer working part-time and 2 junior developers working part-time. So the actual yearly cost for these resources in terms of salaries, and just talking about salaries here, is about $600,000 US. Which means, with the amount of money that we received from Vitalik, from the Ethereum Foundation, with the amount of money that Sigma Prime put in, we're actually funded until July this year. Again, to be very transparent, I'd like to talk about some of the challenges we're facing. As I said early on, we are an information security firm, right? And Sigma Prime's offensive security offering is actually in pretty high demand. So I personally find it quite difficult to find the right balance between Lighthouse and security assessments, right? Sigma Prime is a proprietary limited company. We should be making money, but at the same time, we really want to help the open source space and the Ethereum space by working on Lighthouse. So I personally find that quite challenging, finding the right balance between the two. The spec, that's the second point, is I think a past challenge. We had the spec being updated every second day. We had to throw away a bunch of Rust code, but things are much better now. Much better now. We have release candidates with actual change logs. So that was a pain, but it's almost, I'd say, resolved now. And last but not least, if you were to take the spec and implement it naively, you wouldn't get a working client. You would get a slow client that wouldn't be production ready. So on top of implementing the spec, there is an engineering effort that's required to optimize the spec. Cool. Last slide. Some of the takeaways, I guess, for this project. Should have we waited for a release candidate before starting the work, starting development? I don't know, maybe, perhaps we should have. But at the same time, that iterative process I was talking about allowed us to spot a bunch of bugs in the spec. So these are open questions. I don't have the answer. The second questions I'm asking is, in the ETH2 space, the research team is actually the project management team. So if you come from any commercial background, this is unheard of, right? You would have, people putting the spec together completely separate and independent from the actual project management. But again, can we do it differently? I'm not sure. In a decentralized context, I don't have the answer to this question. And hopefully some of you will come to Sydney for EdCon. That's happening very soon, in a few weeks, 6 weeks, I believe. So we're very, very excited to have the Ethereum community down under. If you guys have any questions about Sydney or Australia generally, please feel free to reach out. But I'm hoping most of you can make it to Sydney for EdCon. And yes, Paul and Adrian will be providing you guys with another Lighthouse update. And yeah, finally, help us get there. As I said, Lighthouse is a public good. So if you're a Rust developer and you've got some free time, please help us. Jump on our GitHub. There's a bunch of good first issues. And if you have any questions, please jump on GitHub. Ask us as many questions as you want. We really want to help you help us. If you're not a Rust developer, and if you're going to be relying on projects like ours in the future, if you are a DApp that raised, tens and tens of millions of dollars in 2017 and 2018, if you are a crypto VC fund who's betting on the success of this space, well, perhaps now is a good time to start thinking about contributing financially to projects like ours. Thank you.